Welcome to Infinite Universe with new interesting episode. In 1982, a Soviet spacecraft called Venera 13 managed to pass through the thick, poisonous clouds of sulfuric acid and land on Venus, the most extreme and dangerous planet in the solar system. The pressure on Venus is so powerful that it can crush a submarine, and the heat is strong enough to melt lead. The sky is always covered with clouds full of acid. Even in these terrible conditions, Venera 13 lasted for a record 127 minutes. It sent back pictures and important data before the intense heat and crushing pressure finally destroyed it. This spacecraft was built to survive even the worst disasters on Earth, but Venus was far tougher than scientists expected. Now imagine a human standing on the surface of Venus. How long could they survive, and what would kill them first? If a person suddenly appeared on Venus without any protection, they would die almost immediately. It wouldn't be because of the heat or the acid, but because of the massive pressure. The pressure on Venus is equal to being 3,000 feet underwater. It would crush a human body instantly. Let's say you're wearing a special spacesuit made with the same technology as Venera 13. The moment you arrive on Venus, you'd notice the air around you is thick and colored in yellow-orange tones. The atmosphere is filled with carbon dioxide and clouds of sulfuric acid, so sunlight can barely get through, making the planet feel like it's always in twilight. But there isn't much to see, just empty land covered in volcanic rocks, cracks, and stones. Your suit is made with strong titanium plates that can handle 90 times Earth's pressure. The weight of the suit is heavy, and since Venus's gravity is just a little weaker than Earth's, you'll still feel it. The temperature on Venus is about 470 degrees Celsius, which makes it the hottest planet in the solar system, even hotter than Mercury. That heat never goes away, not even on the dark side of the planet, because the thick atmosphere traps the warmth like a giant greenhouse. Your suit has many layers of protection, including one made of silicon carbide that can resist temperatures up to 500 degrees Celsius. Inside the suit, a cooling system uses special liquids that absorb heat and move it away from your body. You manage to walk across the fiery ground, surrounded by molten metals like tin, zinc, and lead. The acid in the air constantly attacks your suit, but it holds up for now thanks to materials like gold and tantalum that resist corrosion. The air around you is full of carbon dioxide at such high pressure that it acts like something between a gas and a liquid, completely deadly to life. After a short while, your body starts to feel the effects. The suit's cooling system begins to fail. Even the best technology can't keep up with the extreme heat. Your suit overheats from the inside, and you start to suffer from heat stroke. You pass out, and in less than a minute, the temperature inside your suit becomes deadly. At the same time, the acid and pressure start to break the suit apart. It cracks and collapses under the harsh conditions. You survive for 20 minutes on Venus, a record for a human, but in a regular NASA spacesuit, you wouldn't have lasted even 1 minute. Now let's visit other planets. Your next stop is Mercury, the closest planet to the Sun and also the smallest. What happens to you here depends on which side you land on, the side facing the Sun or the dark side. Mercury has no atmosphere, so the heat is not spread around. This causes the planet's temperature to swing wildly. On the dark side, it drops to minus 173 degrees Celsius, and on the sunlit side, it rises to 427 degrees Celsius. You decide to land on the dark side. As you step onto the surface, the cold ground sends a chill through your boots. With no atmosphere to trap heat, it stays freezing. The landscape looks like the moon, grey, dusty, and full of craters. You can walk around for a while in your insulated suit, but you must be careful not to stay too long. When the sun rises, things go downhill fast. The sun on Mercury looks much brighter and 3 times bigger than it does from Earth because there's no air to filter its light. The temperature climbs quickly. If your suit didn't have strong protection, you would burn from the intense radiation. Even with shielding, the suit starts to heat up. There's no shade, and the next sunset won't come for 29 Earth days. Your suit's electronics start to fail from solar radiation. Your organs begin to shut down even though you still have oxygen. The suit's cooling system stops working. You lose consciousness and fall onto the burning ground. You lasted only 15 minutes on Mercury, taken out by radiation and extreme temperatures. Let's move on to Mars. You land near the equator, not far from where NASA's Curiosity rover touched down. The place looks familiar, like a desert on Earth, with reddish rocks and a pale orange sky. Luckily, you arrived during summer, and it's about 20 degrees Celsius, which feels pretty nice. For now, your suit's heater stays off. At night, the temperature will drop to -70 degrees Celsius, so your suit must be ready. Mars has low gravity, about 2.5 times weaker than Earth's, which makes moving around easier. But there's a problem: radiation. Mars has no strong magnetic field or thick atmosphere, so radiation levels are 20 times higher than Earth's, and even worse during solar flares. Your suit has layers of Kevlar and polyethylene to block radiation. You manage to spend several hours exploring without major problems. You could even build a small underground shelter to protect yourself. Still, Mars isn't a perfect place. The longer you stay, the more the radiation and weak gravity harm your health, slowly damaging your heart, blood flow, and even your brain. After 10 hours, your oxygen runs out. You return to your ship and leave Mars behind. Now, it's time for something massive: Jupiter. Getting to Jupiter is hard enough, but surviving is almost impossible. As you get closer, you face extreme radiation caused by its huge magnetic field, which is 18,000 times stronger than Earth's. It stretches millions of kilometers and traps solar radiation. Only the thick titanium walls of your spacecraft protect you. You descend into Jupiter's atmosphere, just like NASA's Galileo probe did in 1995. It lasted 58 minutes before it stopped sending signals after falling 87 miles into the clouds. You try the same. Your suit is built with titanium, Kevlar, and polyethylene to block radiation and absorb pressure. At the top, you pass through icy ammonia clouds where it's colder than -100 degrees Celsius. But soon, the temperature rises, and the pressure builds. Violent winds throw you into a huge storm. Your suit holds, but your body can't handle the G-forces. You die before even reaching the deeper layers. Your suit keeps falling, untouched by lightning or wind. It reaches the water cloud layer, then sinks to where it's 150 degrees Celsius and the pressure is 24 bars. That's where Galileo stopped. You lasted 3 minutes on Jupiter. Now, let's imagine landing on one of Jupiter's moons, Europa. This moon has solid ground, a thick crust of ice, and a hidden ocean beneath. It's extremely cold at -150 degrees Celsius. The surface is smooth, cracked, and covered in frozen plains. There's no atmosphere, and radiation is deadly. Thanks to Europa's low gravity, you move easily. You see a huge geyser shooting water into space. But then, radiation damages your oxygen system. You feel dizzy, then faint. Even though Europa produces lots of oxygen when Jupiter's radiation breaks water molecules, you can't breathe it. Your suit breaks down, and you die after 15 minutes, just like on Mercury. Finally, you visit Saturn. The moment you look out and see its beautiful rings, you know where you are. Like Jupiter, landing on Saturn is impossible, but you try anyway. You wear a special suit with extra radiation shielding. As you fall into the planet's atmosphere, you see auroras like Earth's northern lights. You enter the troposphere, where deadly storms rage with winds faster than any hurricane on Earth. Yellow clouds made of ammonia crystals surround you. A tiny hole in your suit here would be fatal. Near the bottom, temperatures reach -220 degrees Celsius, and the pressure crushes your suit. Everything freezes. You survive for only 5 minutes on Saturn. But just like Europa, Saturn has a moon that could be promising: Titan. Titan has a thick atmosphere, and when you land, it feels good to finally stand on solid ground. Titan is very cold at -180 degrees Celsius, but your suit is built to reflect cold and keep heat in. It's lined with special materials to keep you warm and safe. The visibility on Titan is very poor because its atmosphere is filled with organic compounds that create a thick yellow haze. This makes it impossible to see Jupiter or any other celestial body from the surface. Despite this, walking around on Titan is not too difficult. The gravity is only about 1/7 of Earth's, so even in a heavy spacesuit, you would feel light and comfortable. The air pressure here is about 1.5 times more than on Earth, which is still manageable for a human in a suit. As you explore the area, you come across a lake that looks just like the ones on Earth. But it's dangerous. This lake isn't filled with water. Instead, it contains a mixture of methane and ethane. On Earth, these substances are gases, but on Titan, due to the extremely cold temperatures, they are in liquid form. After spending an hour on Titan, your spacesuit continues to protect you from the radiation, which is higher than on Earth. But the extreme cold of about -180 degrees Celsius slowly starts to affect your body. Your suit's thermal protection begins to fail, and the freezing temperatures begin to seep in. Eventually, you lose consciousness from hypothermia and collapse on the frozen surface. You manage to survive for 2.5 hours, which is much better than the few seconds you would get falling into Saturn. Titan is incredibly cold, but the next destination is even colder, Uranus. As you approach this bluish-green planet, you realize that another plunge into a gas giant awaits you. Sadly, this experience is also deadly. The winds on Uranus reach speeds of up to 900 kilometers per hour, and the temperatures fall to an unimaginable -220 degrees Celsius. There is no protection that can save you from such extreme conditions. At most, you might survive for 3 to 5 minutes before dying from the intense cold or wind. Instead of diving into Uranus itself, visiting its moons might be a better idea. The largest one, Titania, is only about half the size of our moon. If you weigh 175 pounds on Earth, you would weigh just 4.5 pounds on Titania. With a spacesuit, your total weight might be around 9 pounds. But if you choose to land on Miranda, the smallest moon of Uranus, your total weight including your suit would barely be over 2 pounds. On this tiny moon, you would feel nearly weightless and would have to be very careful not to float off into space. After this near-weightless experience, you move on to Neptune, a planet visited only once by Voyager 2. At first, it looks calm and beautiful with its deep blue color. But in reality, Neptune is terrifying. The temperature drops to about -220 degrees Celsius, and its atmosphere is made of hydrogen, helium, and methane. It also has the most powerful winds in the solar system, reaching speeds of 2,100 kilometers per hour, about 5 times the speed of sound. Radiation is also present, though not as strong as on Jupiter or Saturn, but still enough to damage your suit. As soon as you enter Neptune's upper atmosphere, you are hit by radiation and violent storms. Within just 2 minutes of free fall, you reach a deadly zone and die instantly. The final destination is Pluto, the small and distant dwarf planet. It has a diameter of only 1,480 miles, smaller than Earth's moon. Despite its small size, Pluto has a thin atmosphere that offers some protection from radiation. But there is still a lot of radiation present. When you land, your first task is to turn on a flashlight because it's very dark. The sun appears as a tiny bright star in the sky, and its light takes over 5 hours to reach Pluto. Gravity here is similar to the moon, so wearing a spacesuit isn't a problem. What is a problem is the temperature, which drops to -220 degrees Celsius. As you explore, you see a landscape of ice and rocky hills, similar to a frozen desert. But within minutes, the cold makes your suit fragile. A crack forms, and you die instantly. Your time on Pluto lasted just 8 minutes. Elon Musk believes that if humans want to survive as a species, we must start living on other planets. Exploring and colonizing space would help us survive possible disasters on Earth and give us access to new resources. Mars is considered the best place to start. Musk believes people will land on Mars by 2029, and within a few years, the first colonies will begin to form. However, Mars is a challenging place. Strong winds blow dust everywhere, covering solar panels and making them useless. The surface is covered with small sharp rocks that can damage equipment. In 2022, NASA shared photos of the Curiosity rover's wheels, which were torn apart by the Martian soil. Mars is also very cold, with average temperatures around -60 degrees Celsius. Without a spacesuit, you would freeze almost immediately. The atmosphere is very thin, about 100 times thinner than Earth's, and offers no protection from cosmic radiation. It's mostly made of carbon dioxide, nitrogen, and argon, which are all dangerous to humans. Thankfully, modern technology might help us overcome these problems. Gravity on Mars is only about a third of Earth's, but that's not a big issue. People would need to exercise daily to stay healthy. Elon Musk is preparing people to travel to Mars, but the journey is long. The average distance between Earth and Mars is 225 million kilometers. Driving at 112 kilometers per hour, it would take 223 years to get there. Even at their closest, the planets are still 62 million kilometers apart. The best time to launch missions to Mars comes every 2 years, when Earth and Mars are closest. Then, SpaceX's Starship would launch. Each spacecraft will be connected to a giant reusable rocket with 42 engines. The rocket will push the ship to speeds of 8,650 kilometers per hour, then detach and return to Earth. The journey to Mars would take about 7 months. Once there, the ship will refuel using methane and oxygen made on Mars from local ice and carbon dioxide. Each Starship could carry 100 to 200 people and 100 tons of cargo. Musk says there could be around 1,000 trips each year, and by 2050, there could be a Martian city with millions of people. Houses on Mars will be built under protective domes by robots, or printed using 3D printers. NASA already held a competition for the best Martian house. The winning design was a 4-story ice house shaped like an Eskimo yurt. The rooms inside are connected by spiral stairs and have curved walls to make them feel bigger. The goal is to make Mars colonies independent from Earth. Food would be grown using hydroponic farms powered by solar energy. But we still don't know if Earth plants can grow in Martian soil. To test this, scientists grew plants in moon soil and volcanic ash. They added nutrients, and the plants grew, suggesting it might work on Mars too. Still, Mars isn't the only option. Some scientists think Mercury might work, even though it's very close to the Sun. Daytime temperatures reach 427 degrees Celsius, and there's no atmosphere to block radiation. But underground lava tubes might protect colonists. These tunnels could shield people from the sun and the heat. However, the lack of gravity is a major problem. It would affect muscles, bones, blood pressure, and even increase the risk of strokes. Venus might be a better option because its gravity is almost the same as Earth's. Its dense atmosphere could protect colonists from radiation, and there's a lot of carbon dioxide that could be turned into oxygen. But Venus is extremely hot, about 475 degrees Celsius, and the atmospheric pressure is like being nearly 900 meters underwater. Probes can survive there only for a few hours before they're crushed. It also rains acid and has winds that blow at 360 kilometers per hour. But there's a special area on Venus, about 50 kilometers above the surface, where the temperature and pressure are similar to Earth. Scientists believe floating cities could be built here. NASA has already started designing airships that could float in this part of Venus. They would be powered by sunlight and filled with oxygen and nitrogen to help them stay afloat. The airships would also serve as homes for colonists. At the edge of the solar system, Titan, Saturn's largest moon, might also be a great place to live. Titan is bigger than the moon and looks more like Earth than any other moon. It has lakes of methane and ethane that act like water, and it even rains methane. The surface has dunes made of hydrocarbons, which could be used as fuel. Titan has a thick atmosphere that blocks radiation better than Earth's, and just below the surface, there's ice that can be turned into oxygen. Even though Titan is very cold, the atmosphere helps spread the cold evenly. People could walk outside in warm clothes and a respirator. Homes could be made from local materials, possibly plastic, and built in dome shapes filled with oxygen and nitrogen. Because of Titan's weak gravity and thick atmosphere, it might even be possible for humans to fly using wings attached to their backs. But do we really need to live on another planet? The idea of space colonization isn't new. In 1975, scientists already suggested building space settlements. Now, researchers at Stanford have designed a modern version, a huge spinning ring in space, like a donut, called a torus. It would be 1.6 kilometers wide and hold up to 10,000 people. The spinning motion would create gravity, and there would be areas for living and for industry. Waste materials would be used to block radiation. People would live in apartments on different levels connected by spiral stairs, and they might often see each other upside down due to the spinning. If you could spend one day on any planet without the risk of harm, which one would you choose, and why? Let us know in the comments, and don't forget to like the video and subscribe to the channel if you enjoyed this planetary survival adventure.